Dear students, we will take another example to check whether a function is 1 or not. Let us take a function defined from real number to real number fx equal to x cube plus 1. Let x1 x2 belongs to R and f x1 equal to fx2. This gives x1 cube plus 1 equal to x2 cube plus 1, implies that x1 cube minus x2 cube equal to 0. After using the formula a cube minus b cube, we find x1 minus x2, x1 square plus x2 square plus x1 x2 equal to 0, x1 equal to x2 or x1 square plus x2 square plus x1 x2 equal to 0. x1 square plus x2 square plus x1 x2 equal to 0 is not possible for any pair of x1 x2 belongs to real number. Hence x1 equal to x2 is only possible. Therefore fx is 1 1. Now we are going to discuss about the onto function. Now we will discuss about the onto function. Onto function is also called surjective function. So first we define what is the definition of onto function. Onto function. If f is a function from a to b is such that each element of b is the f image of at least one element of A or in A, it is expressed as f from A to B. Here range of f is equal to codomain of f, that is f of A is equal to B. Now we will discuss method to show onto function. What we have to do? We have to find the range. Find the range of y equal to fx function and show that range of fx is equal to codomain of fx. So we define onto function as if f is function defined from set A to set B is such that each element of set B is the f image of at least one element of A. It is expressed as f A to B. Here range of f equal to codomain of f, that is f A equal to B. Method to show onto function: find the range of y is equal to fx and show that range of fx equal to codomain of fx. We take an example and show by using the concept of mapping. Suppose this is set A, this is set B. There is function f a to be defined. Suppose x1, x2, x3, x4, x5 are the elements of set A, and y1, y2, y3 are elements of set B. Here x1 has image y1, x2 has y1, x3 has y3, x4 has x3 has y2, x4 has y3, and x5 is also has y3. Then this is also goes to y3. That means x4 and x5 both has image y3. So here every element of each element of set B has at least one pre-image in set A. That means every element, each and every element of set B is f image of at least one element of set A. Therefore, this type of mapping is onto mapping. And to check that a function is onto or not, we have to show that range of function is equal to codomain of function. Let us take an example. Let us take a function f defined from r minus 3 to r minus, this is one set 1, this is a set having element 1, r minus this, and domain of this function is r minus, this is a set having element 3, and codomain of this function is r minus a set having element 1, and defined as fx equal to x minus 2 upon x minus 3. So we have to check that this function is onto or not. So for onto we have to find the range of function. So let y belongs to set B, that is y is a value from this set, that means from codomain of the function, and there exists a x belongs to set A such that y equal to fx. So we put y is equal to x minus 2 upon x minus 3. This gives xy minus 3y equal to x minus 2, and we find from this expression x equal to 3y, x equal to 3y minus 2 whole upon y minus 1 belongs to set A. So for y belongs to B, we have x belongs to set A, because we can also say that for real x, y must not equal to 1, because y equal to 1 makes denominator 0, hence x will not be defined. For x to be real, y must not equal to 1. That means except y equal to 1, y can have any value. Hence range of function we can also write r minus 1, which is equal to codomain of the function. So here range of f equal to codomain of f, hence f is onto. We have taken an example. F is a function defined from r minus this and codomain r minus a set having element 1, defined as fx equal to x minus 2 upon x minus 3. For 1, 2, we have taken a y belongs to set B, and we have to prove that for every y, for each and every y belongs to set B, there must be an x in set A or in domain where where A, we have to define what is A and B. Here A is equal to r minus 3 and B is equal to r minus 1. So these sets are r minus 3 is A and r minus 1 is B. So let y belongs to B, that is from codomain, and set A is domain and x belongs in domain, such that y equal to fx. And from this we find y cannot have value 1, that is range must be equal to r minus 1, which is equal to codomain, hence function is onto. So this is the example. Next we will discuss about one on onto both function.